Hey guys, so sharp. Let's talk about the remainder theorem. Ne? The remainder theorem, it says say you have a polynomial p, ne? And that polynomial p you divide it by b of x, and there is b of x, right? So if we take b of x and we solve for x, right, you will do exactly this: c of x minus d equals to 0, blah blah blah. But this is easy stuff, yeah, till we get here. Till you get here, ne? So the value you get here after solving for x, when you substitute it in your polynomial, you get your remainder, right? Yeah, you get your remainder. So what we're gonna do, we're gonna do one example. This one example, we're gonna do long division on it to find our remainder, just to see if this thing really works. Ne? After that, we will then use it. We just need to see that it really works. So long division, x to the 3 plus 4x squared plus 11x minus 5, right? Cool. We do the thing there. You have x squared, multiply, you have x to the 3 minus x squared. Now we are subtracting. You have 0 here, and then here you have 4 minus, it's 5x squared. It's like 4 minus 1, right? Because minus, yeah. Then we bring down these guys. You do your thing, you get 5x, multiply 5x plus minus 5x. We subtract, you get 0 here, and here is the same as 11 minus 5, right, which is 16x minus 5. You do your thing, you get 16x minus 16. You subtract, you get 0 here, you get, that's minus 5 minus 16, that is 11. So remainder here is equals to 11, right? Cool. Let's find what is so b h of x. We have what? We have h of x is x minus 1. So we're like, cool, x equals to 1 when you solve, or maybe starting from step 0. Yeah, so now let's find g of 1. So g of 1 is going to be 1, 4, 11 minus 5, right? And that is, you have 1 plus 4 minus 5 plus 11. So this, they cancel out, the answer is 0, and then you have 11 as a remainder. So it works. Yeah? That means here, if we want a remainder here, you're just gonna say 2 of x minus 1 equals to 0, 2x equals to 1, x equals to half, right? And then after that you find g of half, which is 2, 1 over 2 minus 5, 1 over 2. This is 8. So that, minus 8. Oh, no, yeah, this is 8, and then this should be plus, plus 8, right? Put that in your calculator. I'll just say 0.5 instead of half, instead of 1 over 2. Minus 5, 0.5 plus 8. Therefore, our remainder here is what? Is 7. Nah, our remainder is 7. The same is true for this gentleman there, number 3. The same is true. So first thing first, 5x right? So 5x minus 1 minus 1 over 5. And then you find g of minus 1 over 5. Plus 9, we get how much? Comporo minus 5 minus 1 over 5 minus 1 over 5 squared minus 10 1 over 5. Right, and we get 2, saying therefore 2 is the remainder. I think I saw some examples here. So here they are saying that okay. Okay, so I remember now. So from here is if we divide this by this and r of x is this, the remainder is 16, then find t, right? So you're gonna start here and say x 0, then x equals to minus 1, and therefore you have to find, say this is g of x, right? Now you have to find g of minus 1, and g of minus 1 apparently it gives us 16, right? So you go there, you like minus 1 to the 3 plus t minus 1 squared plus 8 minus 1 plus 21, right, equals to 16. And then this is minus 1. Okay, I have t here. Plus t minus 8 plus 21. Right, equals to 16. So you have t and then you have 21 minus 8 minus 1. So 21 minus 8 minus 1, it's 12. So therefore you have 16 minus 12, and then 4 is t. Right, yeah, that was the idea there. So when that is divided by x plus 1, right, or x, yeah, cool, damn, cool, damn. Cool. So here you have p, you have q, you have p, you have q. Right, so the first thing we will do is here for x plus 1 we have x equals to minus 1, right? And then here we just have x equals to 0. So we go to our equation and say 5 equals to 2 minus 1 3 plus p minus 1 squared plus q minus 1 plus 1, right? That is minus 2 plus p minus q plus 1. So alright, cool. P minus Q minus 1. Or maybe let me say this side I had 5 minus 1. No, plus, right? Yeah, and then I will have 6. Yeah, that's the first thing. Then I substitute 0. Oh, yeah. Here x equals to 4, so not 0, 4. So that means I will come again and say I have 5 equals to, now I'm substituting positive 4. 2, 4, 3. P 4 squared Q 4 plus 1. Right? Cool. Oh, this is Q, this is Q. Right. So now I want to do this now. On this equation, I would say P equals to 6 plus Q. Right. 1, 2. So we're gonna substitute now. You would say 5, 1, 2, 8 plus 16P 6 plus Q plus 4Q plus 1. 5 1 2 8 plus 16 times 6 96 plus 16Q plus 4Q plus 1. I add all the numbers. I have 128 plus 96 plus 1. I'm getting 255. So this side I'll have 5 minus 255. 225. Then this side I am going to have 20 Q. So I have minus 220 20 Q and therefore Q is going to be negative 11, right? So if Q is negative 11, P is 6 plus Q, so therefore here we have 6 minus 11, which is what? 5? Negative 5. Yeah, so just like that we have our unknown. So but yeah, in short, that is the remainder theorem.